Hello everyone. Today I'm going to explain one of the distributions. There are three types of distributions that we will study. Binomial distributions, Poisson distributions, and normal distributions. According to the series, there are two types of series, discrete and continuous. And I have discussed already that what is discrete series and what is continuous. So, based on that, this is a divisions where in the discrete series there are two types of division, binomials and Poisson. And then we have for the continuous distributions, normal distribution is there, and normal distribution is the one of the most important distributions, and it is a bit lengthy also, and it is an important distribution. But it is not like binomial and Poisson is not important. It is also important, and it is recently added in the ANEP syllabus. So we will start studying the binomial trials. So not only the binomial trial, sorry. So first we have to study from this binomial distribution. So first keep in mind that whatever the questions come from the binomial, it is of the discrete series. I mean, it the questions will not be in a range, and the questions which is asked in a range is of the normal distributions, because it is the only distributions for the continuous series. Then we have the binomial distribution. So it is also known as Bernoulli distributions, named after the Swiss logisticians and mathematicians Jacob Bernoulli. So who introduced this method in 1713. So under binomial distributions, the FD falls under the two categories. Thus, it refers to the dichotomous process with reference to the presence or absence of the particular attributes. So, what is binomial distribution? So, it is also important as the Bernoulli distributions. Bernoulli introduced the binomial distributions, and after the logisticians, he's also a logistician and a mathematician, Jacob Bernoulli. And with the reference of his surname, you can also say Bernoulli distributions. Um, in order to say binomial distributions, who introduced this method in 1713. So he introduced this method in 1713. Okay, so this method is too old. Then we have the under the binomial distributions, the FD falls under two categories. Thus, it refers to a dichotomous process with dichotomous process with reference to the presence of the or absence of the particular attribute. So it is like dictavious process with reference to the presence or the absence of the particular attribute. That how much the success rate is there, like present and failure. So it is talk about those things, that is this attribute is present or not. So presence or absence is a matter in the binomial distributions. Then we have the examples like the answers to a questions may be correct or not. So it is kind of a attribute whether this answer is correct or not. So failure and success, it gives the probability that what is the rate of the failure and the success. So the question is similar to that only, and you can see that the question is not in a range. A product may be defective or not be defective. This question is widely asked about defectness or non-defectness. Then, in a throw of coin, chances of getting a head or tail. So, if you are throwing a coin, so if you are betting for the head or maybe for the tail, So it is obvious that the other one become the failure, and whatever you are expecting become the success. So success and failure is constantly in the binomial distributions, if you see. Then we have then we have one more example. In general, the probability of the occurrence of an event is called the probability of getting a success, denoted by P, and that of its non occurrence, the probability of failures, denoted by Q or P1. So for getting a success is denoted by P, and failure is denoted by P, either P or P minus 1. So we already saw the formula where if you are reciprocating the formulas, if the formula question is based on the success and you want to calculate the failure rate, so you just simply subtract it by ones. So is it similar to that? The success rate is P and small p, by the way. So it is subtracted to the 1, and automatically we get the failure failure rate. Okay, probability of the failure. Then there are some assumptions of the binomial distributions. In short, we wrote BD. Okay. Then finite trial. So the binomial experiment consists of a finite number of trial n, and there is a finite number of trial for the binomial. In order to calculate it, because further you will see that n is mandatory in order to calculate the binomial, and to get the n you have the finite number of n which is required. So finite trial is important. So the binomial experiment consists of a finite number of trial n. Then we have the independent trial. So the successive of trials of a binomial experiment should be independent of each other. So the successive trials of the binomial experiment should be independent of each other. That means that success and failures, both are the things, or whatever the trials, they should be independent. It is not like they are dependent, or they are dependent with each other. I mean, they should be mutually exclusive for sure. And that means that it is not a situation, here overlapping situation is not allowed, in short you can say. Then we have the mutually exclusive event. As I told recently, that there are only two mutually exclusive possible outcomes of the experiment. So there are only two mutually exclusive possible outcomes of the experiment. Then we have the probability of an event. So the probability of success P and the probability of failure Q remains the same of all the trials and discrete distribution. So since P and Q express discrete random variable x, and the probability distributions will represent a discrete distribution. So since P and Q express a discrete random variable x, the probability distributions will represent a discrete distribution. So since the P and Q express the discrete random variables, it represent variable x. Variable x is a discrete random variable. Okay, whatever the random variable is the P and Q, then the probability distributions will represent our discrete distributions, right? Then we have the binomial trials. What is binomial trial? So in the probability, any act performed under specific conditions is called a trial. However, a binomial trial is a specific trial that has two features. So, what is binomial trial? So, in the probability, is there any specified conditions called the trial? So, the trial is what? In the probability, an act is performed. You are experimenting something. So, act is performed under specific conditions. So, there are some specific conditions, like there are some assumptions, there are some rules. So a specific condition is there and it is called a trial. Let's suppose I want to take a probability of the number of girls studying in the elementary school, that what are the facilities that the school is providing them to get more efficient educations as compared to boys. So what your condition is, what now you have the gender restrictions, where your gender is specified. You will take all the statistics or the data from the girls, or you are just taking the probabilities. This is the um, like if you are taking a probability, so you are specified with one gender. Okay, so there are some conditions are required, and then some of the specified conditions are required for in order to make this trial successful. So, however, a binomial trial is a specific trial that has two features. So, in the binomial trial, there are two features. First is it gives the rise of the mutually exclusive event. So, here I earlier I just take example, but mostly the question is like of failure and a success. Like, is the female child is getting better education, or is getting education at elementary school or not? So this is like that only. And then we have the probability of p and q remains the same for all the subsequent trial, no matter what number of experiment, what numbers of trials you are performing, but the number of success is constant. If the success is like they like out of this students are getting education and this are not, and then further questions were there. So the percentage or the ratios of the p and q will be remain the same. We will see further. And then we have the binomial experiment. So an experiment is a collection of trials done to obtain meaningful result. When the experiment consists of n number of binomial trial, it is called binomial experiment, or as we know that numbers of trial is called experiment. So an experiment is a collection of meaningful result. If you get the result like this student, this girl is studying from this to this girl is studying from this to this, you are making the probability, right? So or you are summing up, if you are summing up with 100 girls or something like that, so this is called experiment, where you are taking the result or the trial and get a sum up, which is called a binomial experiment. Then we have the binomial distribution. So the probability distributions associated with a binomial experiment consist of n number of binomial trial is called a binomial probability distributions. So the probability distribution is associated with a binomial experiment consists of and number of binomial trials is called a binomial probability distributions. So here the probability distribution is associated with the binomial experiment, where consist. So obviously we will take the experiment, we will not take one by one. So it is based on the experiment, where consist of n numbers of binomial trial. N is denoting what? N is denoting the n number of trial. Let's suppose 200 students were there, so n is 200 and the trial is what? we are taking the probability of all the 200. So these are the things. These are the binomial trial and is denoted by the number of binomial trial and is called the binomial probability distributions, and you can also say binomial probability distribution. Then we have the parameter of binomial distributions. In a binomial distributions, what are the parameters of the binomial distributions? So first is, in a binomial experiment consists of n independent trial. The random variable x is a binomial variable and the probability distribution of this variable is called a binomial distribution. So in a binomial experiment consists of the n independent trial. The random variable x is a binomial variable. So in the binomial experiment consists of n independent trials. So n independent trials were there in the binomial experiment consist, and the random variable x is a binomial variable, and whatever the random variable in the x, let's suppose x is called a binomial variable. We say it as a binomial variable. It is not a random variable. It is, if we are calculating the binomial experiment, so it is called the binomial variable, and the probability distribution of this variable is called binomial distribution. And whatever the probability distributions of the x means the binomial variables, distributions of the probability is called the binomial distributions. Okay, so probability distributions of the x variables, which is also called the binomial variable, so the distribution of that is called the binomial distribution. Okay, probability distributions of that. So what is this? The probability distributions of this variable is called a binomial distribution. So parameters of the binomial distribution is, in a binomial experiment consists of an independent trial. The random variable x is a binomial variable and the probability distributions of this variable is called a binomial distributions. So in a binomial experiment consists of n independent trials. The random variables x is a binomial variables. The probability distributions of this variable is called a binomial distributions. It is denoted as, so what are the parameters? It is denoted by bx, and here the comma is not there. Sorry for the mistake. Wait a second, let me correct it. This comma is not there. This is a comma where it is denoted like x is separated from n and p. N and p are the two parameter and x are not dependent on that. Okay, so denoted by the bxi, and the probability of each value of x depends on the number of trials n, and the probability of success p is given trials. So therefore n and p are called the parameters of the binomial distributions. So here the number of trial and the probability of success p, okay, is given in the trial. So these are the two things you have to calculate it by the questions, and therefore n and p is used as a parameter. So it is used as a parameters of the distributions, whether x is equal to 0, 1, 2, but n and p is the constant which is given in the question. So this determines the solutions, right? you are putting x variables like 0, 1, 2, 3, but n and p are the same, and according to that only you have to put the value, whether from the table or by the formula. So the denoted as the bx, x and p, and the probability of each value of x depends on the number of trial n, and the probability of success p is given the trial. Therefore n and p are called the parameters of the binomial distributions. So the probability of head in a three trial coin tossing experiment will be, so what is the probability of the success p? The probability of success p is 1 by 2. Of course, in the head, whether you are taking, like in the questions, head is taken. So there are two numbers of total outcomes were two, head and tail. And if you are choosing the head, so head is 1, so 1 by 2 is there. And then number of trials, so in the questions it is mentioned that trial con tossing experiment is there. So number of trial is what? Number of trial is 3. Then we have the total sample space. So how we will calculate the total sample space? This is the O to the power n. So total sample space is, there are two, total outcome is 2 and experiment is 3. Then experiment is 3, so powered by 3, and we get the 8. So 8 is the total sample space, and then we have the binomial distributions will be, so b, x and p. So as we have written, then put it like, and value of n is 3, value of p is 1 by 2. So try to put it in the decimal form, because in the table all these things is in the decimal. Here we will calculate it by directly by the formula, but when the variables, when the number of trials and getting a success, especially the numbers of trial is getting larger, so it is very hard to calculate it. So here it is written like x3 1 by 2, so n cx by o to the power n, and you put it all these formulas. And this is the power of combination. So first you have to calculate the binomial, which is bx3 1 by 2. Then we have the n cx and o to the power n. So this is the total sample space what we have to write, na by ns. So na is what, we put the formula of the combination. So here the in the combinations, and in the combinations and by cx. So here r is not there, so variable in the place of the r we will put x. And according to the x, like whatever you have taken, x 0, 1, 2, so we will put accordingly, and n is already given. So according to that this formula is there, so we will further put it, like for the x0, so x and p is there, and then binomial 0, 3, 1 by 2. And then you put it, so when the 0 is there, so it is obvious that it will turn into the 1. So you already know that what is combinations. Combination is what, the formula is, and factorial divided by r in the bracket, and minus r factorial. So when the value is 0, so obviously x is equal to r, and in the bottom if you multiplied by 0, so one answer is there, and whatever the answers divided by the 1 is what is there. So the ultimate answer will be 1. Okay. And the probability of no head, so it is similar to that. You have to put it, and you get the formula. So like 1 by 3 combination is there, 1 you have put in the place of x is 1, and n and p is already given. And then in the combination C1, where the 3 factorial is there and 1 and my subtracted to 2, so ultimately 3 is left, and it is like similar to that where 3 minus 1 is what, 2, and 2 minus 1 is 1, so it is exchanged, so the answer is the same. We have already studied from the combination, and here 3 minus 0 is 3 and 3 minus 3 is 0, so intersections is there, so 1 by 8, 1 by 8. Then we have thus the BD is x is equal to and the probability. So this is what? This is a probability distribution of x. So x is what? Binomial variables. This is a probability distribution. That is why it is called the binomial distributions of the x variable. 1 by 8, 3 by 8, 3 by 8, 1 by 8. So we get the probability distributions of x variable, and this is called the binomial distribution. And then we have the binomial probability rule. So what are the binomial probability rule? Let's begin. Like if x denotes the number, if x denotes the number of success in an trial satisfying the binomial conditions of independent trials. First, you have whatever trial you are taking, they should be independent, and like let's suppose they see this all the trials 0 1 2 3, don't you think that they are dependent? They are not dependent with each other, they are totally independent. You have calculated separately, there is no overlapping, like x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, so all these trials are independent and finite numbers of trial, because as I already mentioned that n is there, n will synthesize the finite number of trial, and then we have the constant probability of success and failure. So there is a constant probability of success and failure. So 1 by 2 is a constant, no matter in which trial you have taken, the probability of success and failure will be not change. If you get the probability of success and failure in one trial, so it is obvious that in every trial the probability of success and failure will be the same, no matter how much you try. So thus it is same that the success rate of the head is 1 by 2, and the failure of the head, that means tail, is 1 by 2. It will not change with that number of trials. So the constant probability of success and failure is there, and that is why in every success or p, you can say, we have written 1 by 2. Okay, so always remember that it is small 2, because small p, because once you are not in practice, so you get confused that probability is also written by p, but probability of success is written as small p. Okay, then we have, then the probability of success in n trial is given by, so here it is px is equal to bx and p, where you can write is so there is a formula n cx px and q n minus x. So this is the formula for the binomial distributions. If you don't have the table, so go for this formula. Okay, so here it is, and otherwise this formula is for tables, like not combinations is there, like numbers is very small, but generally we consider this formula. Table we will further see. Okay, so let probability of success, that is head is of p, is 1 by 2, and probability of failure, that is no head, q, is 1 by 2. Number of trial n is 3, and number of head Now number of probability of head. Okay, so first is the we have taken the zero numbers of trial. Okay, so binomial distribution is x and p, and binomial is 0 3 1 by 2. So n cx, so as we can see that the formula is n cx px q n minus x, and then we put it in the formula, because in every places of the x 0 is putted, and in the places of n, like in the combination n is written here, here n is there, so 3 is written. And the probability of success and failure, because it is a coin tossing, so both are 1 by 2, and in the combination as it is written, so put all this formula and then calculate it. So if it is 0, then it is obviously 1, because in the bottom if it is 0, then it is turned to be the 1. Okay, in the combinations we have already studied. And then we have the 1 by 2 to the power 0, where 1 is this. Of course, if the power is 0, then it is automatically turned into the 1. And here the 3 minus 1 is the 2. So 2 is there. Okay. Mm, 7:30. Hmm. I have done one mistake, like 1 by 8 is there. If it is subtracted by the 3, then it must be 2. And if we multiplied it, then 1 by 4 would be the answer. Then how we wrote 1? Is there anything that I have done wrong? One by 8, and it's just multiplied by 1 and into the 1. So 3 is subtracted by the 1. Oh, that what I have done the mistake. Now I'm getting it is 0, because we have taken x trial, so it will be 0, and then 1 by 8 will be the answer. Some minute mistake will create a big mess. Then we have the px is equal to 1, and then we put it in the formula, and then we get put it in the formula, and then we get 3, it is obvious, then 1 by 2 and 1 by 8. We get the 3 by 8. Okay, 3 by 8 is there. Then in the 2, all this formulas is written, and then we get the 3 by 8. And then in the 3, we put it all these formulas, and then we get 1 by 8, right? And this similar like n c x p x and q and minus x, put it accordingly. N is constant and x is the variable, so whatever you take, the x values will be changed. And then thus the probability distributions is there. Then we will move to the, we have calculated the questions by the help of the formula of the binomial distributions. So as it, like, you can also calculate separately, but this is the authentic formulas that you can use it if the question is not that big, or if you don't have table. Now we have the process of binomial expansion. What is binomial expansions? The process of binomial leads us to the binomial expansion, and this can be explained through, let us find out the probability. One coin toss, so px is equal to 0, probability of no head, probability of one head. Okay, so these are the situations. So first, you have to calculate the probability of head success 1 by 2, probability of no head failure 1 by 2. Okay, so first you have to wrote that what is the probability of success and a failure, and then you will move further to the n is important, n is equal to 1. You have mentioned all the things which is required. Then you will move to the px is equal to 0, px and p 0 1 2 1 by 2. Okay, so now you don't have, okay, like you have written all these things, but the expansion, the binomial, in the expansions, what we have to do is, like the one coin is tossed, so we calculated the number of trials. But what if the number, like one coin is tossed, then the number of coin toss is turned to be 2 3, or in general, so the number of trial is like 1 2 3 4 5, which is 5 and up to 4, whatever is given in the questions, right? So n is there, number of trial is there, but what if the coin toss is 1, then it turn into be 2, then it turn into be 3, and if you are calculating in general, like general number of coin is tossed by the number of trials is like 200 100, you don't know that what numbers of coin is trial, so how you will calculate it? So this is calculated by the process of the binomial expansion, where the probability of head, probability of no head is there. First you have to mention, then n is equal to 1, number of number of trials, and then put it in the formula p, whatever the binomial expansion is, probability x and p, and then we have mhm, mhm. Okay, this is b, sorry, binomial, x and p, and then you put it like, first you have taken 0, then n is 1 and 1 by 2, then put it all the formula, then you get 1 by 2, and then p x1 is similar to that. So here the number of trial is 1, so we have calculated is up to 0 and 1. Okay, so it is started with the 0, so up to 1. And for the above experiment, the total sample spaces, so success and failure is added and it is power to 1, and p is equal to x is equal is 0, and p is plus uh, added to the p x is equal to 0. So q plus p is powered by the 1, and then put it all the formula, and you can also take the step further and put all the variables as it is. And then in general, what you can write, in general you can write q plus p n is equal to n. Okay, so whatever the number 1 is, so in the place of 1, you just simply put n. And then we have the summations. Summation is there because the number of trial you don't know, and is equal to x is equal to 0 because it is started with 0 and you don't know the ending, so it is 0 to n. And then we have the n c x uh, in the combination, then we have the px and then q and minus 1, which is the formula of the binomial, which is written in the bracket, but it is summations because all the experiment is added up. So in short, you can write is summations from x0 to n, and what you get the q plus p powered by n. Okay, then in the 2 cos experiment is similar to that. So I will discuss these things further because this video is already become too long. So till then, take care, bye bye, and I will upload the second part as soon as possible. So bye bye, tata.